In Investigation 1, we wrote a lot of equations, and we were focusing on trying to recognize, first of all, linear relationships, what those equations are like, but we were starting to look at two-step linear equations. So if I have a two-step linear equation, what two pieces of information do I need in order to write that equation? Well, remember, we need the rate and we need the starting point, a starting place. How is an equation of a proportional linear relationship different than our other linear relationships? So remember, proportional is a linear relationship, it's just a very special one. And remember, the equation only has the x term. We could call it, it only has one term. It's that independent variable with something being multiplied by it. It does not have anything being added or subtracted. There's no adding or subtracting in it. Oops. So remember, if it's a proportional relationship, it always just looks like y equals mx. So what are a few examples of equations of linear relationships? If I have a proportional relationship, it's going to look like y equals mx, so maybe something like d equals 13t. A linear relationship, if it's not proportional, remember, then it's going to have something added or subtracted, some kind of starting point. So maybe an equation like y equals 4.5x minus 7. And if I have a linear relationship that has a constant change of 0, remember, that's our horizontal line. It's always the same. Maybe it's y equals 10. Remember when we had a pledge amount, $10, no matter how far I walked, y equals 10. All right, now let's look at how the pattern of change shows up in an equation of a linear relationship. Well, remember the rate, the pattern of change in the equation is the coefficient of our independent variable, which we use x for the independent variable. So the rate is the coefficient of x, or we've talked about it as the number that's being multiplied. That's what coefficient means, the number being multiplied by x, or the independent variable. So if you've forgotten what coefficient means, remember it's the number being multiplied by a variable. All right, how does the start of a linear relationship show in the equation? The start, the beginning, is that number, that constant number. Constant is a number that doesn't change, something that doesn't change. So the constant, or in other words, the number that's being added or subtracted in your equation. So if I have a negative balance at the beginning of the month in my bank account, which would be awful sad, but if I had a negative balance, then I would be starting at a negative number, so I'd have to subtract something in my equation. Okay, now we're going to look at analyzing equations, so understanding what they mean. So we're going to look at where we're crossing the y-axis, what is the steepness of the graph, and whether the graph would be going up or down. You can tell all of that just from the equation. So first let's look at where we're crossing the y-axis. Remember, that's where the graph begins, so to speak. That's the constant number that's being added or subtracted. So in this case, the y-axis will be crossing the y-axis at plus 12. The steepness of the graph Remember, the steepness of the graph is reflected in the rate, and the rate is the coefficient of x. So in this case, the steepness of the graph is 3.5. And lastly, is this graph going up or down? Well, if it's a positive rate, if the steepness is positive, then the graph will be going up, because our rate is we're going up 3.5 every time x goes up. All right, in the second equation, p equals 15, where will we be crossing the y-axis? Well, I don't see anything being added or subtracted. That's because the only thing here is the starting point, is the constant number. The dependent variable equals 15, always. So that means, and the dependent variable is the y-axis, so that means I'm always at 15 on the y-axis. So I'm going to cross the y-axis at 15. What is the steepness of this graph? Well, I don't see a coefficient of x. Well, that's because 0 is the coefficient of x, and 0 times anything is 0, so it just disappeared. The steepness is 0. In other words, there is no steepness. So is this graph going up or down? Well, it's neither. Whoops, I before E except after C. I gotta learn how to spell, don't I? Oh, how come I can't erase that? Guess I'll just have to get rid of it. Okay, it's not cooperating. I'm just going to cross it out. There we go. It's neither up nor down. 0 steepness, it's a flat line. Remember, it's a horizontal line. It's neither up nor down. All right, d equals negative 1/2 t. Where will I be crossing the y-axis? Well, nothing is being added or subtracted, which means I'm going to cross the y-axis at 0, or in other words, the origin. Hopefully you recognize this equation as a proportional relationship, and you knew that a proportional relationship would be going through the origin. Okay, let's look at its steepness. How steep is this graph going to be? Steepness is the rate is the coefficient, so our steepness is negative 1/2. And lastly, is this graph going up or down? Well, because the rate is negative, I'm going down 1/2 every time, so the graph's going down. Remember, a down graph, as you move left to right, it's going down. All right, let's start writing equations from a table. If you recall from earlier, table A, table C, and table D were all linear. And so in order to write an equation, what two pieces of information do we need? We need to find the rate, and we need to find out where we're crossing the y-axis, or where it's going to start. Okay, so in table A, if you remember, we found out that the y values were going up 2 every time, that the x values went up 1 every time. So that means our rate is 2. And the rate, remember, is the coefficient. So y equals 2x. And then we have to decide or find out where we're going to be crossing the y-axis. Well, remember, we're crossing the y-axis where the x value is 0. So you look on your table, x is 0, y is 3, so we're going to add 3. We're going to be crossing or starting at 3 already. So y equals 2x plus 3. Table C, if you recall, was a little odd looking. Remember, I went up 1, and then to get from 1/2 to 1, I went up 1/2, and then we went up 1.5, and then we went up 1. And our x values were also doing something interesting. I went up 2, and then from negative 1 to 0 is 1, and then we went up 3, and then we went up 2. But remember, the rate is a unit rate. How much are we going up for every 1? So remember, we looked at the fact that all of these relationships, all of the change in y over change in x, even though they looked funny, looked kind of weird, they really were all the same thing. They all came down to a unit rate of 0.5. So how does that fit into my equation? 0.5 is my coefficient of x. It's the number I'm going to multiply by x. So that's one thing. And then we have to find out where we're going to cross the y-axis. So remember, where x is 0, my y value is 1. That means I'm going to start at 1. I have 1 already. And lastly, table D. Remember, that had a nice, easy pattern to see. Unit rate, we went up by 2 every time. That the y values went up by 1 every time. So I have a unit rate again of 2. So my y equals 2x, the coefficient is 2. And where does this graph start, or where is it crossing the y-axis? When x is 0, y equals negative 1, so I'm actually subtracting 1 at the beginning. Or you can think of this as y equals 2x plus, I'm adding a negative 1. I'm starting at a negative 1. Both of those mean the same thing. Okay, we need to be able to write equations for story problems. So let's look at this story. Again, if we're going to write an equation, we need to find two things. We need to identify the rate, and we need to identify where we're crossing the y-axis, or where this is going to start. All right. So at 10 o'clock p.m., the temperature is 50 degrees. Throughout the night, the temperature falls 2 degrees every hour. Write an equation to represent this situation. All right, so we've got some great words in here to help us out. I see right away the each, every, per. That means it's our rate. And our rate is 2 degrees every hour, but be careful because it's not just 2, it's falling 2 degrees every hour. So if it's falling, we need to represent that as a negative 2. So our rate is negative 2. And where are we starting on the y-axis? Well, this story begins at 10 p.m. This is where our story begins, at 10 p.m. And at 10 p.m., at the beginning of our story, the temperature is already 50 degrees. So we're going to be starting at 50 degrees. So this story doesn't necessarily start at 0. It starts at 10 p.m. That's our zero hour, you could call it, where we're starting. All right, great. Let's put this equation together. So we're going to start with y equals, our dependent variable, and our rate is negative 2, so that's going to be multiplied by x, and we're starting at 50, and it's a positive 50, so we're going to be adding 50. There's our equation, y equals negative 2x plus 50.